I'm going to talk to you today about two things, cybersecurity and quantum computing. So if we talk about this, we kind of have to couch it, frame it in this idea that I would like us all to accept, which is that hackers are just going to hack. And whether they hack for fun, like script kiddies who've discovered the thrill of the first thing that they've downloaded of the web and, oh my God, if I do this message to you over WhatsApp, I can now read your messages, cool. Whether they're doing that kind of hack, or figure out that they're actually good at hacking and then get motivated by some sort of financial incentive and become little cyber criminals, or when they figured out that they've got fun and profit, but are now migrating to a different arena, which is like a sort of political motivation or hacktivism. I think we need to accept that this is something that we're always going to have to deal with. As long as we live in this digital era, we're always going to have to deal with the fact that hacking is going to happen. But figuring out who did the hack is going to be ridiculously difficult, because in technical terms, we call this attribution. And attribution, in more technical terms, is a shit show. There's a lot of false flag operations. There are lots of copycat operations. We have no idea at any given time who actually perpetrated the hack. And the reason for that is because we all use the same stuff all over the planet. And when it comes to hacking tools, we see a sort of recycling happening. Stuff that was invented for use by the political state actors then trickles down to use by the cyber criminals, and then trickles down to use by the kid down the street who you thought was a pain in the ass and just playing Fortnite. That kid is actually spending his remaining free time trying to hack whatever he can. So if we go with this premise, that they are moving up in this scale, and by the way, this is the FBI's most wanted list, and there are folks on here, the names will change, but you'll see like the geopolitical arena being reflected in what's happening in this space. And then, of course, like we have the state actors who, at this moment, these lines are blurring. And the reason that the lines are blurring, some of you may have seen this, but there was a UN report talking about, the OG gangsta, sorry, that's another technical term, Kim Jong-un actually being the guy who reaped almost $3 billion doing different types of hacking activity. And he did this by, basically ability to execute on things like ransomware programs. And he's managed to do such an enormous scale of ransomware in so many countries around the planet and being very, very successful, despite the fact that actually he doesn't have a huge internet presence. He doesn't have an enormous amount of capacity in the country. And you might be wondering, how is this possible? Because, tiny country, not a lot of connectivity, and yet able to conduct operations of an enormous scale all over the globe to hack all the rest of us. You guys remember the issue with WannaCry and the NHS in the UK? Well, I don't know. I mean, I'm not sure. Just a raise of hand, how many of you know all about that case and where it actually came from? Okay, well, I'm going to tell the story then. Because I don't want to bore you about something that might be very well known here. So let's actually talk about this. What happened is all state actors have the need to have targets that they need to attack. And sometimes they need to create tools called 0 days. Does everybody know what a 0 day is? Does anybody not know what a 0 day is? Oh, okay. So a 0 day is an attack tool. It's basically a vulnerability that is known for 0 days by the manufacturer of the thing who made it. So let's say we have a 0 day in Microsoft Office. Yeah, a lot of people use Microsoft Office, so a 0 day is a vulnerability that can be exploited by Microsoft Office that an attacker would release, where the maker, Microsoft, has no idea the vulnerability exists and therefore cannot fix it. Idea clear? So the longer that the 0 day stays open in the wild with the inability for the maker of the thing to be able to fix it, the more dangerous it is. And 0 days are expensive because you either have to find them yourself or you have to buy them. So a lot of people, when they want to launch an attack against a difficult, hard target, we either buy or we find or make 0 days. Yeah? And the idea here is that the NSA was trying to outsource the production of some of these 0 days. So they used a group called Equation Group. Equation Group was making 0 days for them. Equation Group themselves got hacked by who we think are potentially a Russian group, the shadow brokers. We love these names. So they got hacked. Equation Group got hacked by the shadow brokers, and then the shadow brokers basically dumped the 0 days on an online auction on Twitter. Starting price, 10 million US. Not bad, it's a good deal. But for 0 days on all different types of platforms, on Cisco, on Microsoft, etc. So imagine the global impact. Look, you guys use Cisco. You will use Microsoft products. We all use the same stuff. So does the NHS. So do a lot of banks. So when you saw the 0 day that was used to create WannaCry, MS-1710, it hit like a bomb. And were it not for one security researcher, the impact would have been far more crippling than it already was. So we are not ready for these kinds of attacks. But we do see evidence that they are happening globally. We are playing war games. And I know you guys know that the fifth dimension of warfare is cyber. I don't need to tell you that. But I need to tell you that the collateral damage on critical infrastructure and vital sectors that we need in order to do our information assurance, that is not okay. So if we're going to play the attack game, we need to prioritize better this idea of defense. So I see it on the back of the telecommunications backbone. When I was working at KPN, we would monitor the traffic between networks. It's called BGP, Border Gateway Protocol traffic. And when you monitor this traffic, you see how actors get online, get enabled, and start tending not just good stuff, but also malicious traffic all over the world. So, for example, I'll give you another weird thing. When we were looking at BGP traffic all over the world, all of a sudden, North Korea, which had one line that was continuously getting hit by all types of attack stuff, all of a sudden, we saw a secondary line come up. And a secondary line for North Korea coming out of all places, Russia. And that shouldn't be possible because at the time there were economic sanctions against North Korea. And we saw it on our BGP monitoring protocol traffic before it came out a few months later that there was a violation of the sanction regime. So if you pay attention to telecommunications networks, you see so much more reflected about the current geopolitical state than sometimes any other OSINT or anything else that you could possibly look at. And for us, like in trying to do this information assurance for vital infrastructure, this becomes the only way for us to get information in order to protect the rest of our customers. And the problem that we have is really supply chain visibility. Because we buy the same stuff to protect hospitals and airports and telecommunications infrastructure as you buy. We're all buying the same thing, and they're not always genuinely meant for the purpose for which we use them. So I will give you an example. Telecommunications networks, you can buy from Huawei or you can buy from Ericsson. You can do whatever you want, but fundamentally take a look at where all of that hardware is coming from. And look at the common components in terms of software. When we have a complex piece of kit, whatever it is, there are common software libraries that are used in every single one of those products. Every single one. So if you would have an issue in any part of that supply chain, it affects all of the rest of us. Think about your own supply chain. We had a talk this morning about all of the tools that you might have that, from a consumer perspective in your home, whether it comes from like home vacuum robots or other things. Think about the stuff that you use just on a day-to-day basis. There are a lot of people who don't take their secure phone out in order to have secure conversations. And think about what are the potential for weaknesses in your own environment as an employee and as a private citizen. So I think that we need to take this and really turn this up. If you take a look at the last hacks that we had a hack on an equipment manufacturer, Asus, A-S-U-S. Does anyone have a computer from Asus? Now, don't be shy. Does anyone have an Asus machine? Thank you. Did you guys see the Asus supply chain hack recently? So there was an attack that went out because someone stole the signing key for the firmware of those machines. And they basically sent out an illegitimate update to millions of ASUS users all over the world because they stole the signing key. And you know, you didn't know it, but you got that too. So if you have an ASUS and you actually did the good thing by patching it and keeping it up to date, you also got an illegitimate version of this update. The point is that if you kind of reverse or unpack this update, what you'll see is that the targeting was done for 6 specific users. So the attacker already knew that their targets, 6 of their targets, were using these ASUS machines. But in order to get to those 6 targets, we infected several millions of devices. And this is the real issue with the supply chain problem. We're not talking about a few 100,000. You know, when we have these common components, we have them all over the place. And these common components use common libraries. So we have the possibility for global impact with one hardware or software vendor in your supply chain. And the question is, how well do you have that fully visible and in your control? You know, I've heard the word quantum dropped, like name dropped quite a few times today. Can I just ask you guys, how many of you feel confident that you understand what quantum is and what that threat is? Can I explain it to you in 60 seconds? Let's try. So the clue is as follows. So basically, we have computers on Earth. We all know that, right? Our computers are built in a certain way. They think in a certain way. The whole topology and the hierarchy of them are thought of in a construct the way that our minds work. We know that. And even our supercomputers, which indeed perform computation at a faster rate, are still really cool, but they still think in a particular way because we deal with bits. Yeah? We all know this, right? A 0 or a 1. We all know what bits are. Good? A quantum computer deals with something called qubits, which means that it can be a 0 and a 1, an up and a down, if you will, at the same time. This qubit thing is really powerful because what that means is where you had the space of this one thing, right, you now have already 2 potential outcomes. So we've I did that. That was my armpit. Okay. Sorry. Ugh. Okay, let's go back. I don't know, the guys in the back are going to kill me now. All right. Okay, they're fixing it. That's good, thank you. So the idea, I'll just put this down here. So the idea is we have the 0 and the 1 at the same time. You're all with me, right? Now imagine I do this thing, this funky romantic thing called entanglement, you know. And what we do is, with entanglement, is we take something here, and we bind it. We maximally entangle it so it equals 0. We bind it with another qubit over there. So now I want to ask you, right? I told you that we had a 0 or a 1, okay, with a bit. Now I've got a 0 and a 1, okay? How many outcomes do I have? Right? Good. So now I have entangled it with another pair. How many outcomes do I have? Right. I've entangled it again. Yeah, there's people here that are 8, and there's other ones, I'm sorry, that are saying 6. It's not 6. All right. So you get the idea, right? It's 2 to the n, where n is the number of qubits that we entangled. So again, think about it this way. I've got this opportunity space where I had a 0 and a 1. I now have 3 entangled qubits. I have 8, 2 to the n. And now I have 4 entangled qubits. I have, there you go. And I go exponentially higher. So my computing power, my opportunity space, is exponentially increasing. That is freaking dramatic. And that's why quantum computers are so cool, because they're going to allow us to model scientific phenomena that we now do not have the power to model. Like looking at, atoms in the universe and trying to predict things with all these possible permutations and variations. Scientific questions. We can do that with a quantum computer. Will it make Windows 10 run faster? Probably not. Okay, but it can do all this other cool stuff. So that is why quantum stuff is so cool. The thing that Google's been trying to do, which is the announcement that you might have heard of, that people have name-dropped a couple of times, is about something called quantum supremacy. It means that a quantum computer is now capable of doing something faster than the fastest supercomputer on Earth. Okay? And yes, it can do that. Can it now break all of the cryptography that we use to protect our secrets? And the answer to that is no, it cannot. So all I want you to know is a quantum computer, yes, it's doing all these cool things. Can it actually break the cryptography and ruin our secrets? Not quite yet. But think about that exponential potential for growth, and that's why you should worry. Okay? So that's the really cool thing about quantum computers, because they can solve math problems, discrete factorization and discrete logs that we can't do right now. Okay, so yes, quantum. And I want you to think about what that means for our society, because in order to evaluate how big the threat is, we need to understand how long do we actually need to keep our secrets secret. 5 years, 10 years, 50, 80? If we're getting towards like the span of a lifetime, I can tell you we do not know how to do that yet. We don't know. How long before there's a viable computer, probably from China, that does break our secrets? And it'll be kind of like the Enigma story all over again. When you have the capability to decrypt, you're not going to announce it to the rest of the world so they can then get themselves safe. So it will be a strategically held priority to keep that type of innovation, quiet. And then thirdly, let's take all of the places in your supply chain that hold on to your secrets. How long do you need them to transition to a place that's quantum safe? So even with a quantum computer, we're using post-quantum cryptographic algorithms to keep those secrets intact. Well, this is the real issue, because I don't think that we're going to be able to get that done fast enough, which means basically we're all screwed. Okay. There's only one thing we can all do, which is demand security and privacy. From your hardware, software suppliers, from everyone you work with, from your own family, and from yourself. This is a right. We deserve this, and we need to demand it. So go out there and get it. Thank you.